All right, so welcome everybody. It's a small, intimate group for this presentation, which is good. It's really good, Eunice. Your nerves now can drop, right? Yeah. This presentation is really presenting the work that we were part of with Helen, exploring some of the barriers and opportunities to share knowledge as we advance the opportunity with Inwood. We kind of over the course of a year and a half, we explored through a number of workshops, kind of what we could do to expand kind of the use of wood as it grows and the opportunities that go forward. So it was a research project. And then where we got involved as associated, we have done on our structural side, we've been involved with mass wood since 2009, I think, was Elkford, where we used cross-laminated timber as tall shear walls. And since that time, although we've flown a little bit under the radar, we've had a heavy timber project on the books consistently through all that time. And so we got to understand it fairly well. We come at it from a slightly different sector, perhaps. We come at it from a more institutional, remote communities, small communities, infrastructure type background. So for us, this was an opportunity to be part of research into perhaps the broader market. So privileged to be part of it, really. It's good to see a few more people come in. So I'm going to walk through where we started the project from was a hypothesis, really, that, and I think hopefully all of us in the room would go along with this. Actually, let me just step back a little bit. We have consultants in the room. Do we have any contractors in the room? One contractor. Any architects in the room? No? Sort of? So the rest of you, research people, BIM technologists, modelers? Okay, all right, good. So it's a fair mix. Yeah, you're a student, okay. Yeah. So where we started was that there's an emerging interest in innovative wood systems and supported by modern design and construction processes, and really that's around sustainable design, the advent of new technologies and connections around wood, new technologies around producing cross-laminated timber, nail laminated timber, dowel laminated timber. And Robert and I were just chatting before this, saying that in Seattle a number of years ago, we used to use heavy glulam. It's been around a long, long time. Wood in itself is not a new material. It's the connections and the processes around it, which is evolving fast. And then the opportunities, so further to that growing interest and opportunity, the next part was really that the opportunities for British Columbia's architecture, engineering, construction industry is particularly relevant, and that we can become a leader or are becoming a leader in low carbon wood buildings, both in terms of what's being built in British Columbia, but also the export of our skills and knowledge. And then how do we ramp that up? And so to ramp that up, what we need is leadership that requires prompt resolution of technical and regulatory issues. And those of us that have been involved in the wood world have seen that go on. And that means engaging with new technologies, processes. I read this morning, just coming in, a post on LinkedIn that basically talked about the fact that there's an adequate supply of wood, there's an adequate growing number of suppliers, but there's a lack of the growth of people that can actually manufacture and skilled in kind of the design for manufacture process and things like that. So it's a new set of technologies for the building industry that we've got to grapple with. And because it's changing so quickly, the hypothesis was that we need to perhaps move away from the traditional consultant, maybe even contractor world where we keep our IP close to our chest, and we learn again on each and every project, and rather than sharing it in the broader community. And so how do we facilitate that? And Eunice will talk about what we've built in terms of the details as a sample of sharing that knowledge. Any questions on the hypothesis? Does that kind of ring true for everybody so far? Good. So just to step through why BC, and I think this probably won't be too much news to any of you. the construction to British Columbia's economy is around $16.5 billion annually. And it provides 8% of the province's gross domestic product and employs about 230,000 people. So it's a significant contributor to BC in broad terms as construction, and so we need to continually innovate and move forward, and construction is perhaps always one of the slowest to innovate. So we need to push that as we move forward. Combine that then with British Columbia's reputation for being a leader in green and sustainable design. It's the first province in Canada to chart a path towards net zero. Passive house, it has the most number of passive house projects in Canada, and it continues to move forward. City of Vancouver is moving towards net zero, looking at embodied carbon, and embodied carbon is a real important piece of the wood industry. So in order to move the industry forward, as we hope to, we need a vibrant research and development community, and FII, FP Innovations. There's a number of disparate bodies that kind of are doing a lot of research in this area, and we're trying to bring that all together. The leadership position in wood is a fairly small community. Generally, it's built on here in BC, it's built on a fairly small community of leaders in the industry. I think we all tend to know each other and rub up against each other fairly frequently. For it to really gain traction in every kind of area, that really needs to grow and broaden, and we need to fully engage with British Columbia's kind of world-class wood design community, as well as owners and authorities having jurisdiction. So we need to invest more in innovation. And the hypothesis here is that if we can collaborate together, we can share our information. Okay, any questions? So far, all good?
So far, so good.
So far, so good? Good. And so, here we are, just a little image on the top of the wood project. Just out of interest, this is a wood project that we just completed a month ago, just got occupancy, and it's a research laboratory all out of CLT and glulam. It's one that I think we'll be pretty proud of. We can't say too much more than that, but it's in Comox. Yeah. And the wood, part of this actually probably encapsulates part of the challenge that we face here in British Columbia. The wood came from Europe because it was cheaper.
So just to reinforce that, there was the workshop we did in September in Victoria.
Mm-hmm.
Where you and a dozen structural engineers were in the room talking about investing in CLT from Europe as the 200 logging trucks drove by protesting about mill closures.
Yes. Yeah.
What's the macro reason for that?
Yeah, it's good. I think we'll touch on this a little bit later as well, but I think there's a perception that there's a lack of supply in the industry. Broadly speaking, there's like, there's only 2 manufacturers in BC. One, Structurlam. and Dave, I think there's a lot of perception around it.
I'm not going to have that in my presentation, so
yeah.
a couple comments on supply.
Sure, go ahead.
Yeah, so
David Bell was with FP and
I was with FP Innovation,
yes.
now with FII.
Yeah, okay.
So in British Columbia right now, we have Structure Craft. I think we can hear you.
Yeah, for the people on the audience, apparently. Yeah.
Okay. Yeah, so, yesterday the tour went to Structure Craft. That's a Dow laminated timber plant. So they're doing panels. They also do detailing on CLT and glulam elements from other suppliers for projects. So we have that one supplier. The second supplier in the province would be Structure Lam of Okanagan Falls. They make CLT. They also make glulam products. Then when you go, I guess, a little further afield, you have in Edmonton, you have Western Arch Rib, they do glulam and mass glulam panels. And then out east, the large CLT manufacturers, Nordic. Again, glulam and
Second back to
Quebec.
the living process or something.
I don't
not. No.
There's another one called Element 5 that's in its early years in Ontario. Now, the big announcement this year was that
Kalashnikov,
lumber in Castlegar, I guess you'd say, just outside of Castlegar. They are investing in a CLT plant and a glulam plant. That's under construction right now.
I understand that their glulams are going to start rolling off fairly soon.
Sure. Yeah. And the interesting part about them is that they've been they're in a really interesting belt of fiber where they have interior Douglas fir, large hemlock, etc. And so they're a traditional supplier of lam stock to other plants. And so, yeah, well positioned, and we will be seeing them online this year. So the glulam supply domestic in Canada is going to go up a fair bit this year, and there's a lot coming online from the US as well. So the supply situation is definitely changing in North America, but Europe was very early in the glulam game. They invested, just like we have in North America right now. The governments were very excited about CLT and put some incentives to get CLT production in place. And so they found themselves somewhat in a, at times, oversupply situation. And so when they're in oversupply, they're more than happy to bid on projects over here.
Yeah.
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 So,
a couple of other comments on why I believe that there's been this thing as well, and why I think it's going to change. And others jump in and comment too. But I think Europe's been at it longer than we have. So when they supply a package, they will, they'll pre-drill all of the holes. They'll go much further than traditionally has been done in North America in terms of providing a finished product. So it's quicker to go on site. When you're working with structural, and when we did the first one, they provided the blank panel and that was it. Everything else had to be done, and that's evolved over time and will continue to evolve. Whereas Europe, you get all of your service pipes and everything else already pre-drilled. We know. So there's, but that's evolving and changing, and will continue to do so with structure craft and other structural lam and the competition that grows and things like that. And then the other piece that I'm intrigued to see how this changes things, so that in Europe, each manufacturer has their own load tables, specifications, product grades. You have to go to their design tables to design for their product. Whereas in North America, it's a CSA standard, and it's common across products. And so I think that may change. This is my personal opinion. I think that may change things over the long term, because designers aren't picking a product; they're specifying a material. So it'll be interesting to see how that changes. Back to the project that we were part of then. So the first piece was some research in the market, and again, conversations, talking to people, asking questions. And then we tested what we found from that research in workshop settings, and we did 2, I think, in the course of... Right. And it's ongoing. This presentation today is part and parcel of that research, and so really welcome your thoughts and discussions. What's come out of these workshops is a set of details, and we have a copy of all of the details that you can take away with you. But it's really, if you like, being crowdsourced. It wasn't us that came up with those details. It was the participants in the workshop that came up with those details as solutions to issues that typically would come up in a mass wood environment in the biggest market share. And so some of the things that came out of the research was this play between advancing technologies, the manufacturing plants, where we're moving towards kind of prefabrication, manufacture as it relates to wood in construction, the consultant world, the contractor world, and then this need to information share, and there's kind of this push and pull and changing of the industry in terms of being open with the information, and yet at the same time there's this rapid advance in construction and the marketplace. And I think another factor to add into that is this hugely growing interest in wood as a solution or as part of the solution to climate change in terms of its embodied carbon. There's, I think the jargon is kind of co-benefits. Wood is a structural material, but it also has a lot of co-benefits in terms of health and embodied carbon and beauty and all the rest of it. And so it's really emerging again as a popular material in construction. As a structural engineer, if I may, I'm a great believer in using the right material for the right place and the right time, and that's something that came out of the workshop too. We'll touch on it a little bit later, but if we try and force wood without thinking about how it should be used, then we'll actually do wood a disservice. And then the other thing that kind of came out was in three main buckets. One was around kind of the concept and context of using wood, and where those kind of supporting mechanisms or constraining mechanisms were. So there's the industry norm. There's the fact that here in Vancouver we're a predominantly concrete society. Seattle, I believe, is more steel, but that's the way we've done it for a number of years. And the industry norm, everyone knows it, everyone's comfortable with it, and we can work with it. So that's changing, but it can be either a support or a constraining mechanism to what we're doing. And then there's the authorities having jurisdiction. And again, what we're seeing is that this is changing, but you can go from jurisdiction to jurisdiction and get a very different reception when you talk about doing a timber structure. And so then it becomes a supporting or a constraining mechanism. And market influence. Market influence has a huge part to play. If people start to want wood, then we'll find that it drives the other things really, really quickly. Any kind of comments, questions, things that we've kind of missed? This came out of the research as these three buckets. And then, so in the next bucket, so that was kind of concept and context. What is the context that we're moving forward with this wood project? The next one is the system selection, and this comes back to using the right concept for the building and the right material in the right place. And then, when we're looking at a system selection, all of these things play into that. The typology of the building, the pricing of the material, the product availability, the education of the team that you're working with, all the way through from the owner through to the sub-trades. They need to all be on board with that. Market awareness, building requirements. Here in Vancouver, as we'll see, we've got specific zoning requirements that can play into the effectiveness of using wood. So we need to look at all of those things as we move towards a wood solution and the trends there. And then the last piece that came out of the research was the need then to, once you've settled on the context for it and the system selection and said, yep, this is going to work, this is how it's going to do, and then it's how can we optimize the solution with respect to the building configuration, the building envelope, structural design, building code, zoning, building policy. All of these things factor into the end result, no different to any other typology or material that we use. But timber is a very different material to steel and concrete, and we need to design accordingly. And then the last piece that came out of those workshops, and this is just a couple, was as we tested those things and we did some research, was that there's not really a coherent way of sharing information and lessons learned from project to project. So how do we gather that information? And one of the ways that we focused on was kind of your typical details, your interface situations where you've got building envelope with wood, floor to floor, you've got noise considerations, those kind of things. So how do we do that? And then how do we open source that information and make people aware of it? And then Eunice later on will just touch on where we think you could further share that information. So. All right. So that was the research. And so based on that research, what we came to was this kind of, okay, we should focus on those parts of the market where wood is probably going to have most traction. And so whilst we at Associated deal a lot with infrastructure and smaller communities, the main market is kind of residential, commercial, mid-rise, high-rise. That's where a lot of the material is going to be used. So for us, it was a privilege to be part of this, and be sponges, if you like, as we worked with some of these experts. And so we picked, with the help of Helen, we picked 4 case studies for the workshops. And really the workshop was designed to kind of test those buckets. Does that make sense? Where are the barriers to adoption of these emerging trends? And so we picked a 6-story mixed-use residential in Vancouver with the kind of zoning requirements, but also the supportive authority having jurisdiction, and how would that interplay? A 4-story multi-tenant office in Victoria. Victoria was picked, if I remember rightly, because it's high seismic zone. And no, that was Surrey, I think. Yeah. Yeah. 8-story seniors residence in Surrey. Poor soil, so on the floodplain there. And then a 4-story, so mixed-use commercial building with a supermarket. And I'll just quickly go through some of the plans just to give you some context, and some of the challenges that we addressed in the workshops as we try and do these things in wood. So the 6-story mixed-use residential, fairly typical with the setbacks. 6 stories now allowed by code. In fact, it's now soon to be 12 if it's not already 12. And so we have to deal with these kind of things. So we put a daycare on the roof, which I think was pretty nixed and consistently in every workshop was a bad idea with a wood building because of sound issues and all those kind of things, fire protection and things like that. And so it comes back to that context. And if you're going to design it in wood, how do you deal with those kind of issues? Get that sorted early on, right? Setbacks, so you've got transfer systems, building envelope issues as you transition from external balconies to internal balconies, and how do you deal with wood systems there? And I think this one had a 0 lot line. Again, so how do you deal with that? Just check my notes here just to make sure this was a passive house too. Yes. So how do you deal with that thermal 0 lot line, prefabricated system of building, mass timber? How does that work? Does that work? Is it practical? Is it feasible? Yeah, so some of the things that kind of came out of that was, the daycare on the roof I already touched on, the setbacks required by Vancouver zoning bylaw, alternate solutions for passive house 0 lot line. How would we get around that? Thermal performance at the transfer slab between residential commercial occupancies and transfer floor meets the elevator shaft, seismic design, and then the blindside passive house timber firewall assembly.
Did you actually resolve some of these issues like went through the workshop?
Yes.
Fire assembly?
Yeah, we, and we have a set of the details hard copy there, and we did resolve them. It was, I think there was probably around 25 to 30 people. Architects, engineers, contractors, code consultants, building envelope, and really crowdsourcing at its best. Are they final? Are they complete? Probably not, but they're a base point to start with. And as you'll hear, the hope is that we can continue to build on that community. And what was interesting was, I think generally there was very quick consensus that it could be done, but we just need to consider it from a wood systems perspective. This was a 4-story multi-tenant office in Victoria. Victoria was picked because it's a high seismic, and so that tends to give challenges around transitions from the diaphragms to the cores. As a structural perspective, you've got a high seismic zone. You're going for a timber core. How does that affect the core design? Is that possible? Is that feasible? And then introducing the wood design into a building typology that's primarily been built out of concrete. And here, this one, I think we completely redesigned this one. This one was, I guess, with an atrium in the middle of it, kind of a typical, what you would say, commercial, multi-story, big glass front glazing. And what came out of this loud and clear was, for this to work in wood, you really need to configure it differently. It's too difficult almost to do it as is. And so that was really interesting. As again, kind of speaking to that, the constraints here with that atrium, with fire protection, with all kinds of different issues going in there, in-floor services, envelope implications, the protection of wood. It becomes challenging, and so we need to rethink it if we're going to do it in wood. Not to say that it can't be done, but that was kind of the message there. So that was fascinating to see that come through. I think one of the comments that I've written here is that this project represented how past design and construction assumptions work against the potential benefits of wood. It doesn't tend to work if you come with a building layout that's set out for concrete and a commercial expectation. The column patterns set out on a commercial space expectation, and then you just try and fit wood into it. You kind of have to rethink the system.
So really that decision to go wood should really be made earlier on.
Right. Yeah.
So the consideration between two materials needs to be made.
Yeah, exactly. And and I think this will come out a little bit later on. The drivers behind the decision, what's driving that decision, and how important is it to the owner? Is wood just a nice to have, or is it actually a fundamental design philosophy? Because it will change the expectation around that building.
So you mentioned you're going to talk about that a little bit later on?
I'll touch on it. I mean, we kind of picked out on some of those things going forward. Yeah. So this one, and this perhaps speaks to the advantages of wood in a different way. So this one was 8-story in Surrey. So the case study, and bearing in mind that these were meant to be realistic, but they were case studies. So we kind of threw things in there just to test things. So this was poor soils, and it was designed, and so there was a couple of potential advantages in moving to a wood system. One is that it's lighter than the concrete system, and then so if it's lighter, the thought is, well, okay, that's going to help with the foundations, but maybe we can get an extra story on there too if we're clever. So how does that work? And does a wood system lend itself if we use a tighter column spacing with just flat plates for the floors? Does that help us at all? And we explored that. So the poor bearing strength of the site source meant that additional foundations may be required for a concrete building. The height restriction, maybe we could get extra floor space in here if we're kind of good with that. But then because it's a residence, there was this, and this came up a number of times, was that interface between the balcony and the internal space, and how do you connect that with the envelope? That's a common issue. Doesn't matter what material you're using, but with the wood, how do you protect the wood from the in a satisfactory way? I'm not sure that we really solve the extra floor issue. I think we got focused in the workshops. We got focused around those details, the interface details. We had a couple of ideas. In fact, we had some crazy, there were some really out of the box ideas, but there was one or two that will be in that pack that I think they're a good starting point for sure. Yeah. And then here there was talk of how flexible is this in the future if we want to change use.
You mentioned earlier that the site had poor soil conditions. Did that have an impact on the footing foundation designs?
Yeah, we didn't. Yeah, I mean, we didn't design the foundations in the workshops, but I mean that's a generalization. Sorry, it has poor soil conditions, the floodplains, the where there's potential liquefaction and things like that. We have to deal with that. And so the thought was, well, if we're dealing with a structure that is a quarter or a fifth the weight of concrete, then there's opportunity there for us to help. Yeah. There's a big difference. Yeah.
I mean, you sort of lose some of that if you're doing parquets. In fact, we ran this one again. Because it was non-market housing, we tried it without the parquet to see if that made it more. Because then I think you really do see the effect. But,
Is there analytical software that you run through?
Yeah.
What is it?
Yeah.
The calculates actually.
Yeah. Yeah, I mean, those of us that are, there's a whole host of analytical material tools that we would use. Some of them plug into, well, most of them now plug into Revit, so you can kind of transition between the two fairly easily. Yeah.
Like calculating and using the analytics based on wood.
Yeah.
Yeah, really.
Yeah. I mean, that's and those of you that are in this space too can jump in and comment here, but I've seen a real change with the analytical, the number of options you have when choosing analytical tools that deal with cross-laminated timber and glue dams and things like that. So when we started, the only software that we could get that dealt with cross-laminated timber was a German software called Global RFM. And so we then had to do a conversion between German products and Canadian products. Now, for sure, the S-Frame suite has it. We're just looking at SAP right now, but I know for sure there's kind of an ever-growing, and Woodworks is a great package for some initial sizing and stuff like that.
Yeah, I mean, you'd be getting a lot of information out of it.
Yeah. Not to well, S-Frame for us has been an interesting one because we started with RFM, which is German, and it's good. S-Frame, their wood package actually, because they're here in Richmond, is one of the few that tends to keep up with the Canadian codes, we find. But yeah.
Because the structure is so light, we're more concerned with vibrations.
Yeah. Yeah, for sure. Yeah, no, that's so when it diverges a little bit, but I think it's as good. I think some of the key things that we hear about wood, number one is fire. Like how does it respond in fire when we're talking to people that have never done it? How does wood deal with fire? Number two is sound and vibration. There's because it's lighter, it's bouncy and it's noisy too. So you have to come up with floor assemblies that damp it out. Usually put a concrete topping or a sound absorbent thing. You want to add some mass into it, right? And fire, it performs very predictably in fire, mass wood. The analogy that I often hear and have said myself and will say is, 2x4s, 2x6s is like kindling. It's like, what you use to start your fire with. It's really thin and it just burns. But once you get above a certain section size, it burns at a pretty predictable rate, somewhere between 0.6 and 0.7 millimeters a minute. Yep. Sorry, brain just went blank then. Yeah. And so you can calculate it, right? So if it's a 45-minute hour rating or an hour rating, you can calculate that.
Ratio or application on surface area as well.
Yeah. So depending how the wood is exposed, if it's exposed like this, if this was a wood beam, it would be exposed on three sides. And so you do the calculation on three sides and reduce the section, and then do a calculation on the serviceability loads that are applied on that beam. Yeah. But it's actually more predictable in some ways than steel in fire. Whilst steel heats and then it gets soft and then it buckles.
There's been some classic pictures I've seen where you see a building burn down and you'll see the glue lamps of the steel beams like spaghetti laying over the timber beams.
Yeah.
Really? Yeah, because the rate of burn is slow, and yet when the steel heats up, it loses its strength quickly. It's very plastic.
Yeah. So.
And that really goes with it, even with the metal connectors. Increasingly, you're trying to hide your metal connectors inside of the wood.
Right.
Away from
Right.
the metal connectors.
Yeah. But the perception, and it comes back to that market awareness and owner education, is they see the fires of the mid-rise stick-built things, and they think, wood burns. I'm sure wood burns, but it's predictable. And then the last one, which is a bit of a change, was 4-story commercial over a supermarket. and you see this all over the place. And then, does this lend itself to wood? Can we change the configuration to suit a store at the lower level, and then typical commercial space above that? We had some great ideas come out, but again, it comes back to the right material for the right purpose, and the dealing with the lateral and transverse systems. The wood system tends to get quite heavy at that transfer system because it's a lot of load coming in. So you need to think about that. And then alternative solutions for the two types of assembly, commercial space over retail space, thermal performance, noise, vibration, and structural layout kind of adjustments, things like that.
There's also the hybrid solutions, which are infinite.
Mm-hmm.
Hybrid solutions are quite useful in this application too, where if you've got long span, you keep it in concrete or steel and go up with wood when it becomes feasible. Right?
Absolutely, yeah. I couldn't agree more, and I think that's what came out loud and clear in the workshops was, let's think about this holistically, hybrid. Yes, we want to use wood, but we want to use it in the right place, and then that will actually lead to greater adoption, I think.
So there's quite a bit of considerations around construction and logistics and material handling as well. I was involved with a project where the spec required that the contractor maintain 45 RH for the material during construction. So the building's not enclosed. So how do you do that? You build a tent and build inside the tent. What's RH?
Relative humidity.
Because spikes, changes in humidity spiking can cause the wood to have checks and splits. And if it's a really terrible split, it can destroy the integrity potentially. And then of course, checks are not attractive. So the spec required us to maintain 45 RH during construction.
Yeah.
You do that. Stuff's wrapped in plastic.
That was interesting.
And you have to have a controlled, if you exchange, control it slowly so they can come down, etc. So there's material handling constraints. You got to store this stuff in a dry facility until you're ready to install it. You got to keep it
wrapped.
As impossible. And then you might end up taking on an inevitable liability. To maintain certain conditions because you build a building. Yeah,
for sure. It's that is one of the challenges that I think we probably should look to Europe a little. Like Europe tend to build under their tents, but that's quite expensive here, right? Wrapping is a solution. Putting. I mean, this is something.
Sun discoloration as well.
Yeah.
And then in the final condition, if you're using something that goes to the exterior of the building, thinking about the types of sealants and that sort of thing, how they react to the time of sun, humidity, and whatnot. And then matching the color discoloration from interior to exterior. Completely agree. I mean, I think we've learned some lessons. I think the first project we did was using product from Structure Lamb early on, and it came unwrapped into the site in Elkford. They've changed the way they do things now, but UV staining was a real issue. Just for just a couple of days, even you have the panels lying kind of not stacked up neatly, but with the piece showing, and then you'd see that outline, and there's no way you can get rid of it after that, right? It's there. Another one that same kind of thing, membrane, but it was wet, and the membrane was put down without it drying out properly, and then it just peels off, right? It's understanding wood as a material and what you can do and how to avoid those things. The RH one is a really interesting one. So project that we did up in the Yukon, it was a really small, actually Martinsville was the same. So the relative humidity was really dry, and then it dried out too quick and we got checks, right? So, and now, I mean, thankfully both owners love it. they loved the kind of the natural look of it, but it wasn't what they were expecting at the outset. Was this checking? Yeah.
Craft would be challenged with that as well, right? Construction, fabrication of the element here in modeling,
yeah,
and then shipping it to even the Okanagan or to the States in a dry climate.
They will. They're targeting to 12% moisture content in their wood. And so depending on where you're shipping it out, well, typical kiln dried wood would be 19% for stick frame buildings. So they're getting it dried down to 10 to 12. Your service conditions are going to be in your sort of 8 to 12. But getting into the Yukon in the winter, that's extreme. It may be lower than that.
Yeah.
So, they try to mitigate it through that. They will.
If they acclimatize their material all the way up.
Yeah, to some degree. Now, keep in mind this whole discussion around the UV and such, and even the checking. When we talk mass timber, most of it's going to be covered.
Yeah, that's what I was just thinking.
So, you have to, if you have a very sort of wood forward one where your CLT pounds are going to be uncovered, that's one thing. Most of the time, it's your glulam beams that are going to be uncovered. So, you can be more strategic in what you treat with the kit gloves.
Yeah. I think we all know it's natural material. See some checking is.
We had some other issues arise, like cumulative drift tolerances, because the connections are slip critical, so there's no wiggle room.
Interesting.
The way they come together, so that you're building a facade, and over the city block of the facade that were together slip critical connections, we had a drift start to accumulate across the facade, and we're applying a glazing system to that that's made out of aluminum. That has a tighter tolerance, so that across the facade you start to see the aluminum and the wood starts to depart from each other.
Interesting.
Resolve that as we go forward. So
that's interesting. Because typically, what our experience has been that the drift has been less than kind of a in situ build.
But there's no tolerance. Tolerance for the types of conditions.
Yeah. All right. We're getting to you soon here. This is great. I thought I was going to struggle to go for an hour and a quarter. This is fun. This is awesome. So then we looked at kind of what were the solutions and for these things, and we've touched on a whole bunch of them. So I can rush through this. So one, so around the concept and context was the kind of that developing a holistic understanding of wood and how it works, and just and we can kind of do that. And understanding the limits, the code limits of the place that you're working in, making sure that you're not putting unnecessary barriers in the way right from the start. The holistic understanding, material, structural characteristics, constraints, broad design, construction strategies, everything that we've kind of touched on already. Making sure that the whole team understands that right from the get-go is really, really important. And then build awareness with owners. And I've kind of put up here knowledge, learning, training, coaching, but kind of just build awareness of open forums, ask all of those questions that you have around it, build some confidence in what you're doing, and opportunities, advantages, prefabrication, modularization, and how we deal with that over time and share the lessons learned. I think I'd hate to see that this industry kind of keep things to themselves and not be open about the lessons that have been learned along the way. Kind of when it comes to system selection, material aside, and this is fairly obvious, what are the overarching priorities? Is it to have wood, or is it to have a commercial space that sets the norms? Is it? Are there other things that drive it? We need to be clear on that right from the get-go. Understand the client's requirements, the owner's requirements. What is it that we're trying to achieve here, and can we do that in wood? And how do we do that in wood, or a hybrid system? Maybe a hybrid system works better for that. and then the strategies for achieving those goals, work on those. And again, a lot of the conversation that we've touched on already speaks to that. And then recognize, and we've touched on this, that to optimize and to really draw it forward, it has to be collaborative. We're talking about a different way of prefabrication, understanding where the supply is coming from, the constraints of different suppliers, how that is moving forward. And I think we spoke earlier about this need at the beginning of the project to have all of those conversations and get all of these things out on the table. I mean, this could be for any kind of project, to be honest with you, but particularly so here, where perhaps not everyone on the team fully understands what it is to deliver a wood building. Let's make sure that we're all on the same page, and then that will hopefully reduce the effort later on and the changes and things like that. Francois and I were just chatting earlier about integrated project delivery, the contract there, and how that should drive some of that, the sharing of knowledge, the incentive to be collaborative and things like that. And we're starting to see that as a method of delivery. So that's not what this presentation is about. So, and then out of that came out a long list of recommendations, which is on the report, which we'll show a link to that. But one of the things that came out of that was this development of details that came out of the workshop as we try to wrestle with all of these things. How do we solve that? And so the recommendation there was to build a culture of information sharing, organize that information effectively, including organization of the innovation and the ideas and crowdsourcing, and develop a bit of a component catalog. And this project was backed by FII. And so what they've done is they've hosted this on their website. The report is there, and the details are there, and Eunice will speak to that in a minute. But the hope is, and the intent is, and be good to get your feedback on this, that this becomes a collaborative effort, an iterative effort, as we kind of build knowledge and we can add notes to it and things like that. And so with that, I'm going to hand over to Eunice, because she was the one that did all the hard work in putting all of these details together. And she's going to talk a little bit about what we've done on the website and how we built up the details and show you some examples, but then also future cast out a little bit about what we might want to do with that in the future. So just bear with me while I switch my microphone. Let's just click that one, yeah. Put that in the pocket. All yours.
Hello, everyone. My name is Eunice. So the main effort I put into this project is to help develop this smart detail using parametric families. So the main face issue in the industry is there's usually a difficulty finding the information, or even you find them, there's always overwhelming unfiltered information. So the key considerations for me to come up with these details are the information data in the family has to be easily transferable, and the detail searching and implementation process needs to be efficient. And lastly, the material use and the design concept when it goes to construction phase has to be affordable. So the link up there can take you to the full report of the study, and you will have the opportunity to download the full PDF studies with all the details, or you will have the option to download case by case if that's your interest. Also, there's a full Revit file in 2018. In there, you can find all the smart details for all the case studies. So these are just an example of all the details you can find in Revit, and as well as this handouts. This is just one of the example of how any of the families is going to look like. So, for example, the CLT glue lamp floor, I embed with all the details were created in drafting views, but instead of using the annotative lines, I make them into using detail items, such as line-based families or using genetic families with regions. So they have the colors and hatches and all the graphics that you want. On top of that, I built in the parametric values. So in there, you'll find the material used, its length and width, any suggested manufacturer, and you can also put in the supply unit price by linear feet or dollar by square feet, as well as any of the code requirements, specification, or if the professionals have the additional comments. So now that the details is not just annotative lines, we can easily extract its values and use into calculations. So once you pulled all the details into your Revit models, you can then use the Dynamo with Revit to easily extract all the data information that you want. Using the extracted width and length, I can calculate the cross-section area for materials and times that by the distance of the details that's going to be in the buildings. I will have the material values. And since you have the suggested manufacturer and your unit price, you can easily figure out your cost estimate for quantity and material use. So for business, this will be a good way because you will have your data to support your project proposal, or for designer, they can easily use this information for the conceptual design analysis. And since we have all the material values, then we can run that with to run a embodied carbon report. So using a lifecycle assessment. So on the right-hand side, the green table, I just do a sample model. So I pulled in 3 details, 1, 2, 3, and from there I calculate all the total cross-section area per materials in each details. And the left top is the distance per details per level. So with all that numbers, then I can come up with all the materials within the building per level. So what is lifecycle assessment? It is analysis techniques to assess environmental impact associated with all the stages of a product's life, which is from the raw material, processing, manufacturing, distribution, and to its end use. There are 2 common carbon emission during the construction. One is the embodied carbon, which you can find generally from the structure and building envelope materials. The other one is operational carbon, which you can generally find from the carbon emission from the energy use, water reuse, biogas, from the electrical and mechanical equipment. At Associated, we're passionate about building community that are vibrant, healthy, and resilient, and to support the economic growth. So sustainability is part of every project that we undertake and how we operate our business. We recently launched a building information label system to measure and track the embodied carbon and operating energy of a building. we want to start building a database for all the embodied carbon that we calculate compared with the actual greenhouse emission. So here's just a simple equation of how you calculate the embodied carbon. Since we already have the material quantity estimation, we will time that by the embodied carbon per material. Then you'll have your full report or estimate of the whole building embodied carbon. It's similar to calculate the operational carbon. What you will need to get instead is the value of the space, the use of the room, and then you'll have your design equipment list. So after that, you have to determine your equipment fuel type. For example, if it's natural gas, biogas, or electricity, they'll have different emission rate. And so that will be kilogram CO2 emission per kilowatt hours. So once you have all these information, you can come up with your estimate for the whole building for the operational carbon. These are just some software public out there that you can use to calculate your carbon emission. So for Beacon and one-click LCA, they're real Revit plugin. They can just restrict data right from your Revit model. EC3 and Athena Impact Estimator are mainly used for the material embodied carbon. Tally is really good for lead application for environmental sustainability. IES and RET screen are for energy model. So with that, because our new construction is like rapidly growing, for the industry estimation for the next 40 years, every month we're gonna build a New York City. So can you imagine how many buildings that? So I think from now on, we need to not just make our design and construction efficient, we also need to make our building performing efficiently.